Hello everyone, and welcome back to the Fluctus Channel. Jet fuel becomes a different military problem once aircraft are pushed far beyond air bases. Fighters, transporters, helicopters, and special mission aircraft all depend on fuel constantly. Yet in austere theaters, there may be no permanent storage tanks, no secure pipelines, and no convoy route safe enough to keep a forward strip supplied for long. That is where the US military found an extreme solution: move the fuel system by air. Instead of waiting for infrastructure to arrive later, crews can transport flexible storage containers, set them up in remote terrain, and create a temporary fuel capability where none existed before. In effect, the base does not just receive fuel, it receives the means to build its reserve. Aviation fuel is not just another cargo. It has to remain clean, stable, and tightly controlled because it feeds engines operating at extreme temperatures, high pressures, and speeds. Any contamination, leakage, or careless transfer can damage aircraft, interrupt operations, or create a major fire hazard. That is why the military treats fuel as both an energy source and a system. Every gallon is part of a chain, and that chain must work from storage to delivery. One of the most practical tools in that chain is the fuel blavet. A blavet is a collapsible fuel container designed for expeditionary use. Essentially, a flexible tank that can be folded, transported, secured, and rapidly deployed where a rigid storage tank would be too heavy or too slow. What makes the blavet valuable is not just the amount of fuel it can hold, but the fact that it can be packed into the logistics flow, flown or trucked forward, and turned into temporary storage almost anywhere. To an outside observer, it may look like a giant fabric bag. To a fuel crew, it is a deployable node. The locking and logistics process shows how serious that role is. A blavet has to be positioned carefully, secured against movement, connected properly, and integrated into a loading plan that accounts for weight, tie-down points, and safe transfer procedures. Crews do not simply throw a container into place. They align it, check the fittings, route the hoses, and make sure the whole system can travel or operate without shifting, tearing, or leaking. That idea becomes even more striking when fuel bladders are placed inside aircraft. The aircraft is no longer just carrying supplies. It is carrying the backbone of a future fuel site. In preparations for a forward arming and refueling point, crews inspect the bladders, service them, and configure them for airlift so that once they land, a remote site can resemble a functioning fuel farm. The cargo aircraft becomes a bridge between a developed base and an empty location needing aviation support. The loading process inside a C-17 makes the concept vivid. Bladders have to be filled and prepared with close attention to cargo procedures, restraint, balance, and safe handling. Weight distribution matters. Cargo placement matters. The air crew and fuel specialists must ensure that the aircraft can still fly safely while carrying the equipment that will later support flight operations on the ground. That is why the first aerial bulk fuel delivery system mission in U.S. Air Force's Central's area of responsibility since 2017 was such an important real-world event. It proved that a C-17 could again move the core pieces of a refueling system into an austere environment. Once that aircraft landed, it was unloading endurance, range, and the possibility of sustained operations where no fixed fuel facility existed before. Once the aircraft has delivered the equipment, the challenge shifts from transportation to construction. What was cargo in the air now has to become a functioning storage site on the ground, often in heat, dust, open terrain, and time pressure. This is where the scale of bulk fuel work becomes impossible to ignore. Large fuel bladders are not light items that a few people drag into place. In major support operations, they become giant pieces of infrastructure, demanding manpower, coordination, and physical effort just to position correctly. In one large bladder support evolution, roughly 100 personnel were involved in rolling out a single large bladder. That statistic changes the whole image. A massive bladder is not just a storage container. It is a temporary tank farm waiting to be unfolded. Crews have to guide it, spread it without tearing or twisting, keep it aligned, and prepare the surrounding site so that it can later accept fuel safely. When a large bladder is being replaced for an entire base, the stakes rise even further. Removing the old system and bringing in the new one means preserving the fuel backbone for everything that depends on that facility. Installing open-air fuel bladders pushes the process from manpower into engineering. Marines and bulk fuel specialists first prepare the ground, making sure the area is usable, safe, and arranged for storage operations. The bladder is then positioned and opened, its shape gradually taking form as crews guide it into place. Connections have to be aligned, fittings checked, and spacing managed so that the site functions as more than a pile of containers in the desert. It has to operate as a controlled storage network. That is where fuel line drills become essential. Once the bladders are in place, the next question is whether the fuel can move where it needs to go. Crews lay out hose sections, connect couplings, verify seals, open and close valves, and rehearse transfer procedures until the network can carry product reliably. Every section of hose matters. Every joint becomes a leak point. Every pressure change has to be understood. A line drill is not busy work. It is the moment when storage becomes distribution. Detailed process is everything here. Hose paths have to be planned so they do not kink, chafe, or cross dangerous areas. Valves must be identified and controlled so fuel goes to the right destination. Teams monitor the line, watch for pressure issues, and stay ready to react if a coupling slips or a seal fails. This is how the military turns open ground into a working fuel reserve. When the system is built properly, fuel can flow from a giant bladder through a controlled hose network and onward to the units or aircraft that depend on it. At that point, the desert stops looking empty. It starts to look like an improvised, functional fuel storage facility built from fabric tanks, connectors, manpower, and disciplined drills. And because the site is temporary, mobile, and built for austere conditions, it represents a specific kind of military strength, the ability to create logistics capacity where no permanent capacity exists. What arrived by aircraft as a difficult load is now a real fuel reserve on the ground, and the next step is to turn that stored fuel into flight line support. But a storage site only matters if the fuel can be trusted and delivered quickly to aircraft. That final step unfolds on the flight line, where fuel operations become faster, louder, and less forgiving. Here, the challenge is no longer simply storing the product in bulk. It is moving clean fuel from the storage system to live aircraft without delay, contamination, or accident. This is where hot pit refueling, fuel distributors, tank removal teams, and fuel laboratories all become part of the same story. Hot pit refueling is one of the clearest examples of the speed-driving process. Instead of shutting an aircraft down, waiting through a slower servicing cycle, and starting it again later, crews refuel while the aircraft's engines are still running. That means the aircraft can spend less time on the ground and return to the mission faster. But it also means the margin for error becomes smaller. Ground crews move around noise, heat, exhaust, spinning rotor hazards, and flammable fuel at the same time. Every step has to be deliberate. The aircraft is marshaled in, grounding procedures are followed, the hose is brought forward, the connection is made, flow is monitored, and communication stays constant until the aircraft is ready to disconnect and depart. Fuel distributors are the specialists who make that tempo possible. Their work links storage to delivery. They receive fuel, manage transfers, issue it where needed, and keep accountability over the quantity and quality of jet fuel and related products moving through the system. They are the people who turn a fuel reserve into a vital support system. The same system also has to be maintained and upgraded over time. When a storage tank or component has aged out, failed, or needs replacement, crews do not simply tear it out and walk away. Fuel tank removal is controlled work around hazardous material, structural concerns, and contamination risks. The tank has to be emptied, disconnected properly, lifted or dismantled in sequence, and removed without turning maintenance into an emergency. That process reveals something very important. Fuel infrastructure is never static. One of the least visible but most important parts of the whole operation is the fuel lab. A gallon of fuel can look acceptable and still be unfit for aviation use. That is why fuel quality checking is an inevitable part of the process. As soon as the fuel lab receives a consignment, samples are collected and tested for water, particulates, contamination, and other problems before the product is cleared for use. The lab protects engines, aircraft, and crews by catching problematic fuel before it reaches the aircraft getting ready for the flight line. In that sense, the lab is as vital as the pump. Seen together, the full chain becomes clear. Fuel blivets and airlifted bladders make it possible to move storage by air. Giant teams roll out that storage in the field. Fuel lines turn it into distribution. Hot pits turn it into rapid aircraft turnaround. Fuel distributors keep the product flowing. Tank removal teams preserve infrastructure over time. Fuel labs guard the quality of every gallon. The extreme solution the US military found was not simply flying jet fuel into remote areas. It was flying in the means to build, operate, test, maintain, and trust a complete fuel system wherever the mission required. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.